What's up, Math 1? This is Mr. Bainey, and we're going to take a look at 11.2, solving linear systems by substitution. So how can you solve a system of linear equations by using substitution? So far, we've learned how to solve a system of linear equations using graphing, and now we're going to switch to an algebraic way. So take a look at this system right here, y equals 2, which we could graph in a coordinate plane, x plus y equals 6, can also graph as a line. So if we know that y is equal to 2, that means y is 2, the value of y is 2, so we can change the other y to 2. So in part A, instead of x plus y equals 6, we can put x plus 2 equals 6. And if x plus 2 equals 6, you subtract 2 on both sides. So x is 4, which means that our solution is, our x comma y. X is 4, y is 2. And that's where they would intersect if you graph them. In part D, now you see these two systems right here. So this is slightly harder. If y is equal to 4x, this time y, we don't know the actual value of y, but we know that y is the same as 4x. So instead of y, right here in the other equation, we can put 4x. It's going to be 5 plus, instead of 2y, it's 2 times 4x, and that equals 39. Then we just go through and we solve it. So 2 times 4x will give us 8x. Then we combine like terms, just go through and solve it. X is 3. Now that we know the value of x, we use that to figure out what y is. So if y equals 4 times x, we can change that into y equals 4 times 3. And that gives us 12, which means our solution, 3, 12. If we were to graph it on the right, which I'm not going to do, it would intersect at that point, 3, 12. On the following page is going to give us some steps to using the substitution method when we have much more complicated problems. So feel free to refer to those if you need to. I'm just going to go straight to one of the examples. The Your Turn here at the top of page 494. We want to solve this system of linear equations by using substitution. So what we want to do is get one of the variables by itself. So I have the x right here, y here, x here, y here. So you want to look at, if I were to solve one of these equations for x or y, which one would be the easier one or the more efficient one? And let's go ahead and do that. So in the first equation, it is much easier to get the y by itself there. It doesn't have a coefficient number in front of the y. So we'll just have to do one step. If I subtract 3x on both sides of that equation, then we end up with y is equal to 14 minus 3x. So y is equal to this thing, which means I can substitute that thing in for y. So that's going to go into the other equation. Instead of 2x minus 6y equals negative 24, it's 2x minus 6 times this thing right here equals negative 24. So I'm going to write that down. And we solve this. Not given a whole lot of space here, so I'm going to try my best to keep this organized. I got 2x. When I distribute the 6, it's actually a negative 6. So make sure you multiply negative 6 with both of the things inside. It's going to give us minus 84, and then plus 18. Then combine like terms. I got 2x and 18x is going to give us 20x. I'm going to add 84 to both sides. When I add negative 24 plus 84, 60. So x is 3. Then I go back. I suggest using your original equations. We know what x is now, so I can change that to 3. I can change that to a 3. Figure out what y is. Or you can use this one I've written in blue. So instead of x, I put a 3 there. So it's 14 minus 3 times 3. And that one will probably be the easiest one to use. And that gives us 5. Again, thinking back to the last lesson where they intersect, if we were to graph them, that would be the 0.3, 5. And that's our solution. Looking at some special cases on the next page, we have number 7, number 8. I'll do the first one. I'd like you to try the second one if you pause it right after I'm done with number 7. So I want to get one of the variables by itself. And so you see the x here has the negative 2 in front of it. The y has a 14. This x doesn't have a number. The y has a negative 7 in front. The x right here is going to be the easier one to get by itself. I'm going to add 7y, since it's a negative, to both sides. And I get x equals 14 plus 7y. And that means x is equal to this 14 plus 7y. I'm going to replace x with 14 plus 7y. Instead of the negative 2x in the first equation, it's negative 2 times 14 plus 7y. Plus 14y equals negative 28. Then we go through and we solve it. Now, I already mentioned that this is going to be a special case. Let's see what happens. Negative 14y plus 14y, that's 0. We end up with negative 28 equals negative 28. Now, thinking back to when we solved just regular one variable equations, this meant something, and it still means the same thing. Actually means that, first of all, this is a true statement, right? Negative 28 is equal to negative 28. And that means that no matter what we plug in, whatever the solution is to the first one, it's also a solution to the second one. So it doesn't matter what we plug in, it's going to be a solution. And that means infinitely many solutions. So it doesn't just intersect at one point, it intersects at a bunch of points. And that really means that it is the same line. What I mean by that is if you were to graph this first line and then you graph the second one is exactly the same as the first one. Okay, go ahead and try number 8. In about 5 seconds, the solution is gonna show up. For number 8, I solve for y in the first equation, got y by itself. I use that thing equal to y to substitute it into the other y, and I got this equation. I went through and I ended up with this false statement, negative 24 equals 18. And that tells us that there are no solutions. Now, thinking about that in terms of a graph of both lines, that means they're not going to intersect. There's no point on one line that's also on the other line. So they have to be parallel lines because they're never going to intersect and never going to touch. Okay, so these are the only two special cases. Remember that the first case, what will normally happen is they're going to intersect at a point, and we can find out what that one point is. Okay, I'm going to stop there, and that's it for this lesson. So hopefully that helped you. The practice problems are essentially the same as these. So as always, come and see me if you have any questions. Have a great night. Thank you.